We're looking at our function generator set at 51 cycles per second sine wave. Up here is our power meter. We've set that to a 4 ohm impedance to match our exciter, and the scale is set to 2 watts. The lower setting, where a full needle deflection is 2 watts. It's a logarithmic scale, so straight up and down is 1/2 watt, and that's the power we'll be operating at today. And it has a corresponding 3 LEDs brightly lit when we're at that power. Our orthosonic vehicle employs a 40 watt capacity 4 ohm exciter attached to the center of an aluminum disc, which I hand cut, and it's not a perfect disc, but it's about 6 inches in diameter, and the thickness of the aluminum is 1/64 of an inch, or using this caliper, it's about 0.4, this says 0.39 millimeters. That's about twice the thickness of the 6-inch oak tag disc, which we had formerly used as a wing with this exciter. Now, for our payload, we'll be looking at this full can of Campbell's soup, which has a net weight of 305 grams, but with the can and this connecting apparatus, it was measured precisely at 350 grams. And I have a spring scale. It's not quite as accurate, but it'll give you a sense that with 1 kilogram here and a 1/2 kilogram here, we're coming in at around 350 grams there. So we'll use that, and we're going to connect that to our orthosonic lift vehicle by this little S hook. And I'll take the power up to a little past the 1/2 watt. You can hear it's not very loud, but when I connect it here, that's our 1/2 watt. And that is 1/10 of the power used for this incandescent nightlight, or about the power for this LED, which is suspending this airborne against our flight deck today. I have a countdown timer set at 1 hour, and I'm going to let that count down, and we may come back in a while and see if we're still suspended, and that will be the point of this experiment today. We're coming into the last 1 minute. I'm going to move the camera a little bit forward here so that we can see a little better. There's our orthosonic lift vehicle. There's our countdown timer that started at 1 hour. We have 34 seconds remaining on that count. And let's go here. We're running at 51 cycles per second, and at a power, if you look on the power meter, you'll hear a beep when the timer hits, but if you look at the power meter, you'll see that we are running at 0.5 watt